All right, go get a sweatshirt. Because since you're going to school in California, you probably won't spend the rest of your life in California, so you'll need a sweatshirt. And that way you can carry Cal Pride outside of this fine steaks. What do you mean I can't stay in California? I'm just... All right, you ready? Shh. It's 11:11. I'm going to make the wish that everybody goes quiet. There we go. All right, excellent. We're so close to the end of this class, it's really sad. We've got 7 lectures left. I don't know what I'm going to do with myself Tuesdays, Thursdays from 11 to 12:30. I may have to sit at Free Speech Cafe and talk to random strangers about economics. It may happen. Okay. What we did last time is just sort of acknowledge the fact that everything we're doing here just looks at a single market, right? So there are other markets in this world, and most markets, or many markets, are linked through either the supply or demand side, right? So partial equilibrium analysis, which just looks at one market in isolation and holds the rest of the world constant, ignores the fact that, if you charge a specific tax on movie tickets, that raises the cost of movie tickets. That means some people will no longer go to the movies, but will go rent movies. That raises the price of rented movies. That then again feeds back into an increased demand for movie tickets and so on. And after that whole process is over, what we're getting is a much higher price for consumers of movie tickets from that specific tax. If we look at the world in a general equilibrium sense, than if we were to look at it in a partial equilibrium sense, right? So general equilibrium effects are important. When you go to graduate school, and I see you again in a couple of years, and you're sitting in a much smaller room in VLSB, wishing you wouldn't have listened to me and gone to graduate school, we'll talk about things like SUTVA, right? Which is a word to a handful of people in the world. It's stable unit treatment value assumption, right? It essentially means no general equilibrium effects, but it has a fancier word. So this stuff is really important. Just keep that in mind. Then we moved on to our first market failure. Whoops, are you okay? All right. We want no injuries in this classroom. So then we moved on to our very first market failure, and the one we chose to study was monopoly. Well, you didn't choose anything. I chose it for you, but that's the best way because I know everything. No, I don't. But so monopoly is a single firm produces the entire market output. That means since the single firm produces the entire market output, it faces the entire market demand. So I can't say this often enough. This will seem obvious to you now, but when I ask you the same question on the final, you'll be like, oh, he said that 6 times, and I can't remember what it was. Right? For a perfectly competitive firm faces the residual demand curve, which is flat. A perfectly competitive firm, no matter how much it sells, gets P dollars per unit. So its average revenue per unit is P dollars. Its marginal revenue per unit, if it increases output by 1 unit, is P dollars. No matter what it does, it gets P dollars per unit. Right? That's the competitive firm. The monopoly, since he or she faces, I'm going to call the monopoly an it, okay? Because this whole gender thing is tough with the monopolist. So the monopolist faces the decision how much to produce, but by choosing how much the monopolist produces, it doesn't work here. I'm going to go with he or she again. He or she also determines what market price is going to be. So by choosing the optimal output quantity, the monopolist also chooses market price. This is very different from the perfectly competitive firm, which just chooses output quantity because price is determined in the market. Right? So what we've got here now, and what we're going to see in a second again, is that A, marginal revenue isn't constant for the monopolist, and average revenue is not equal to marginal revenue for the monopolist. Right? For the perfectly competitive firm, our average revenue was equal to marginal revenue was equal to market price. For the monopolist, average revenue is still going to be market price. That's the number of dollars the monopolist gets per unit. But marginal revenue is no longer going to be equal to price. Why, Max? Why? Well, let me show you again. Right? Last time I drew this crazy picture. Whoa, fancy new chair for the instructor. Nice. So this notion of average versus marginal revenue is most easily seen if you draw your picture. It doesn't matter whether you use big Q or little q. It's the monopolist. Monopolist produces market output. So if this is demand here, that looks beautiful, Max. Okay? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go from producing 1 unit, that's terrible. Let me try that again. That's better. Okay? At 1 unit, the monopolist would get $8 per unit. If the monopolist now decides to increase output from 1 to 2 units, price drops, right? Because he or she faces the entire market demand, it drops to $7. So now total revenue is going to be 2 units times $7. So it's pretty easy to see in your mind that before the monopolist was selling 1 unit at $8, total revenue was $8. Now he or she is selling 2 units at $7, total revenue is $14. Marginal revenue, which means the change in total revenue due to an increase in output by 1 unit, is going to be 14 minus 8, it's going to be 6. You can do that in your head. But what we said graphically last time is the monopolist graphically loses this area right here, right? For the first unit he sold, he no longer gets $8. He gets the same price for all units, so he now gets $7. So for the first unit, he loses that $8. But since he's selling 1 more unit now, he gains this whole area right here. Right? This here is minus 1. This here is plus 7. So marginal revenue is going to be 6. So the same number we would have gotten if we would have subtracted 8 from 14. If we do the same exercise, and in case you're wondering why is he doing this again, it's because people don't get it, even if I do it 10 times. So I'll just do it twice, all right? And then we'll do it a couple more times in review session. But the point here is marginal revenue $6 everywhere? Every time I increase output by 1 unit, does marginal revenue go up by $6? The answer is no. The easiest way to see that is, for example, see what the price would be if you were to produce 6 units. Okay? If you were to produce 6 units, you would get for each of those 6 units sold, you would get $3. So total revenue would be $3 times 6 units. Total revenue is $18. Now, if you increase output from 6 to 7 units, because you are the monopolist, at 7 units, price is now, because I picked this nice linear downward sloping demand curve here, price now drops by $1. So for all 7 units sold, you now get $2. Right? Before, you sold 6 units and you got $3 each. So now, in some sense, you get hit. For the first 6 units you sold already, you no longer get $3 for those. You only get $2 for those. So you lose $1 each for those units, which means, if you want to call it a fine, you can. It's not really a fine, but you lose this rectangle right here, because for those first 6 units, you no longer get 3, you get $2. So you pay the 6 times $1 fine for the price dropping. However, you now sell 1 more unit. You sell that 1 more unit at $2. So you take in an additional $2 for that 1 unit. So the blue area here is going to be plus $2. So here we get plus 2. Here we lose 1, 2, 3, 4, 5, 6. $6 minus 6. That means marginal revenue is minus 4. Let's see if this is right. At 7 units, I get $2 per piece, so $14 in total revenue. At 6 units, I get $3 per piece, $18 in total revenue. So I go from $18 in revenue to $14 in revenue. I lose $4 in revenue. So the change in total revenue due to a 1 unit increase in output, which is our definition of marginal revenue, is minus $4. So marginal revenue here is minus $4. This is really fundamentally different from what happens for the perfectly competitive firm. The perfectly competitive firm, if price is $5, for each additional unit sold, marginal revenue is $5, no matter what happens. Why is that? What does the demand curve look like that a perfectly competitive firm faces? Thank you. I like it. I sort of gave you a hint. Didn't work. You didn't even see that. So the point here is it's horizontal, So whatever you sell, in addition, you always get the same price. Marginal revenue is constant. For the monopoly person, the monopolist, it isn't. It goes from positive to negative. It's 6 up there. It's minus 4 down there. You could pick another couple of quantities, and you'll see it goes from high to low pretty nicely. Well, next, that's really exciting. I'm very excited about this. But why should I care? Why do we care about marginal revenue? Yes. That is the $100 answer, and it's correct, So the profit maximizing output choice for the monopolist or any other profit maximizing firm is where marginal cost equals marginal revenue, So if marginal revenue is no longer this demand curve, Because you may think, well, maybe this demand curve here is marginal revenue. Well, here, marginal revenue is minus 4, but this curve is 2, so the demand curve can't be the marginal revenue curve. The marginal revenue curve is now a totally different thing. So we're going to derive a new line. Wow, Max, finally another curve, just what I needed. That's right. We're going to draw the marginal revenue curve, and I'm going to try and walk you through it in ways that make sense to you, So what does the demand curve tell me? So if I sell 6 units at $3, I get $3 per unit. We gave a name to the term, certain number of dollars per unit, and that term was average revenue, It's the average number of dollars I get for each unit sold. So what the demand curve tells me is, the demand curve tells me for any quantity, I go up, that tells me the average revenue per unit sold. So at 6 units, I get $3 per unit. So for all 6 units sold, I get on average $3. At 4 units, for any unit sold, I get $5. So the demand curve tells me the average revenue per unit sold. But what curve tells me the marginal revenue per unit sold? And the answer to that exciting question, ladies and gentlemen, is the marginal revenue curve. So let's derive it, Now, I have... and Fiona and Walter and Dan can tell you that this is, my graduate class is even more annoying than my undergraduate class. I have all these cutesy little terms. Convenient fact, then there's useful facts, then there's a note, and then there's stuff that comes out of nowhere, Convenient fact, let me convince you of something, If your inverse demand curve, which we've just called the demand curve, price on the y-axis, Q on the x-axis, if your inverse demand curve is linear, which means it has an intercept and then it decreases at a constant slope, the marginal revenue curve has the same intercept as the inverse demand curve, but twice the slope. Whoa, I need to be convinced of this. But let's go through this for a second, and then I will prove to you that this is the case, hopefully, and then we will work with this. So if the inverse demand curve is price, as a function of quantity, is A minus BQ. That means it has a y-axis intercept A, and for each additional unit drops by B units. I am arguing that the marginal revenue curve has the same y-intercept as the demand curve, but it drops at twice the rate that the demand curve does. What this means is, as it has twice the slope of the inverse demand curve, the marginal revenue curve hits the x-axis, or the quantity axis, halfway between the origin and the point where the demand curve hits the x-axis. Now, this is true for linear demand curves. If you have funky demand curves that are nonlinear and look all cool, you need really hardcore software to draw it, that's not true. But we're only going to work with linear demand curves, and the intuition carries over to the more complicated stuff. So can we show this? There's a yes with 1, 2, 3, 4 exclamation marks here. So the answer is an enthusiastic yes. So let's figure it out. All right. I don't know if I'm ready for this. Let's do it. I wrote this down nice and cleanly here, so I apologize for spying on my notes. At this point, I should be able to just teach this stuff out of my brain, but yeah, limited RAM. So what I'm going to argue is that the marginal revenue is a function of quantities A minus 2BQ if P of Q equals A minus BQ. We want to show this. So when you're trying to prove something, and this carries through to graduate school or in household budget negotiations, always put at the top of your sheet of paper what you're trying to show. It's a nice reminder to see where you're trying to get to. So I'm trying to get from, this is my inverse demand curve, to my marginal revenue is a curve that has twice the slope of the inverse demand curve. Okay. Marginal revenue is price plus the change in price over the change in Q times Q. Max, where on earth did this come from? I showed it to you last time. It comes out of calculus, but since all of those words instill terror in the hearts of undergraduates, let's just quickly see where this comes from. So what I'm saying here is marginal revenue is price plus the change in price over the change in Q times Q. So what's the marginal revenue of increasing from 1 unit to 2 units? Okay, it's price, your new price, times 1 unit, So what area here is P dollars high? It's this blue bar right here, This is exactly 1 unit wide and P dollars high. So this is the additional dollars I take in from selling that additional unit that I didn't sell before at the new price, That's the first P right here. So let me draw some arrows here. So this thing here is this little P in that equation. Now what's the second term here? What the second term here says is marginal revenue is whatever price I get for that additional unit I sell, plus whatever penalty I get for now getting a lower price per unit on all the units I already sold. So for the first unit before that I sold, I got $8, but now by increasing my output by 1 unit, the price goes from $8 to $7. So for that 1 unit sold, the change in price due to the change in output here is I go from 8 to 7, so it's minus 1. For all units sold, for so far it's just 1 unit I sold before. So this here tells you the height of the red rectangle, and Q here tells you the width of the red rectangle. that number is a negative number. Because what happens if you increase output, what happens to price? Crashes, right? Law of demand. Hate given goods, out with given goods. We don't care about given goods. Okay? But the point here is, if I increase output, price drops. So the second term right here, that's the red area in this picture. So let me do one more quick confirmation of intuition here, and then we'll go back to math. I love math. You don't. I know. Let's see if this holds for this move from 6 to 7 as well, right? So from 6 to 7, what's marginal revenue? It's P. So a 1 unit increase in quantity, I get P dollars for it. So that's the blue area. And let me draw that. We get it, Max. Stop drawing. Well, I don't know. Okay? So again, that's the blue area. And then the penalty of this lower price, right, because you're producing more output now, you're going from 6 to 7 unit, price goes from 3 to 2. That penalty is not just paid on 1 unit, but it's paid on all of the units you were selling before. So before you were selling 6 units, but for each of those 6 units, you now get $1 less. So the subtraction here is going to be the change in price due to the change in output, 1 unit, height of this box, times quantity, the number of units you sold before. So it's the area of this red box, right? That's marginal revenue. So the way you can do it in your head is it's blue area minus red area. If red area is bigger than blue area, it's a negative number. If blue area is bigger than red area, it's a positive number, right? Marginal revenue can be positive or negative. Okay, so that motivates the math. You can also just show it using the chain rule in calculus, but nobody likes the chain rule. I would lie. I love the chain rule. The chain rule is great. But this is what marginal revenue is, right? We showed it graphically. I've now gone through some painful explanation of what you'd otherwise do by just invoking the chain rule and losing 90% of the classroom. So hopefully we're on board that this is right here. So now what I'm going to do is the following. I'm going to, in here, plug in demand. And in here, look at the slope of demand. What are you talking about, Max? What I'm going to do is, I know what P is, right? P is A minus BQ. And I want to know what the change in P to the change in Q is. That's just the slope of the demand curve, right? So let's do that. P, right, that's just this thing right here, is A minus BQ. That's the first part. So this, too many squirrely brackets maybe, but plus, now the change in P due to the change in Q, that's the slope of the inverse demand curve. Price is a function of quantity. That's going to be this. Ooh, there's a minus missing. Hold on, we want the minus. That's going to be this number right here, right? If Q goes up by 1 unit, price drops by minus B. Price changes by minus B units or drops by B units. So the change in price due to the change in quantity is the slope of the inverse demand curve. It's going to be minus B. So that's this thing right here. So what I've got is plus minus B times Q. Do you see it? A minus BQ minus BQ. Whoa. Wow, Max. That's incredible, right? I just used a whole bunch of calculus and you didn't even notice it. We never took a derivative. If the dean's listening, I didn't use any calculus, but the intuition is clear, right? We motivated this equation using our picture, and then what I did here is I plugged in inverse demand and I plugged in the slope of the demand curve, and that gets me what I was after. So now if you're a fancy math person and you're in graduate school, you have 2 ways of demonstrating that you're cool, right? You don't even have to get a tattoo. The choice here is you can either draw this, that means done with my proof, or if you're one of those annoying Latin types like me, right? 9 years of Latin in high school, you put QED. So you're either this type of person or you're that type of person. Please do me a favor, use this one, okay? Much less pretentious. QED, quod erat demonstrandum, with a German accent. There you go. What we set out to prove, right? Or what had to be proven. Latin's a little bit rusty. But the most important question we should answer about this particular slide here is, do you have to be able to derive this on the final? No. Okay. The second most important question I'm going to ask you, am I going to assume that you know that the marginal revenue curve has the same intercept as the inverse demand curve, but twice the slope? The answer to that is an absolute yes. All right. So you don't have to know how to derive it, but we're going to draw this so many times that you're going to be comfortable with it. You're going to draw a demand curve and a marginal revenue curve, and you're going to figure out the monopolist's optimal output quantity using those quantities. All right. So just a quick check that we did everything. Can we show this? Yes, we did that. All right. Before we get, and the title of this slide is suboptimal, as they so often are in this course, I promised you a long, long time ago that I'm going to show you that the monopolist's optimal production choice is a little bit counterintuitive. So before we show exactly where the monopolist produces, I want to show you something very general, and it's a little piece of insight that's going to make you a better economist than your peers who didn't take any economics. That was supposed to be funny. Because if you took economics and you're a worse economist for taking it, that's not good. Okay, here's my demand. 2, 4, 6. Boo. Let's try that again. Let's do 10, 10. Okay, so this here is demand. Okay, it intercepts the x-axis at 10, and it intersects the y-axis at 10 as well. So this is an aggregate demand curve where intercept on the y-axis is $10, intercept on the x-axis is also $10. So we've got 1, 2, 3, 4.